You fetched binary data from a FastMCP server. Now what? The real power comes when you can actually use that image, PDF, or other binary content in your application. We'll walk through the exact steps to read binary resources, inspect their metadata like MIME type and size, and save them directly to disk, all with just a few lines of clean, reusable code. You'll see how FastMCP handles the heavy lifting while keeping your logic simple.
Async with client. Content equals await client, read resource. Resource, / images / logo, PNG. For item in content. If hasheter item, blob. Print F binary content. Len item blob, bytes. Print F MIME type, item MIME type. Hash save to file. With open, downloaded logo, PNG, WB, as F. F write item blob.
This demonstrates the resource abstraction pattern for handling heterogeneous content types through a unified interface. The code treats both text and binary resources as first-class citizens, using duck typing to determine content handling at runtime rather than through explicit type checks. What makes this distinctive is its protocol-agnostic design, where the same client interface works for files, database records, or custom protocol resources. The pattern works by returning standardized content containers that expose either text or blob attributes, with metadata like MIME types attached. This creates a consistent consumption model regardless of the underlying resource type or transport mechanism. The separation between resource location, URI, and content handling means clients focus on what they need from resources, not how those resources are stored or generated. This approach solves the common problem of content type fragmentation in distributed systems, where different services might return JSON, images, or raw bytes through inconsistent APIs. It's particularly valuable in microservice architectures, or when integrating with multiple backend systems. The trade-off is a slight abstraction overhead, but the benefit is a dramatically simplified client implementation that can handle any resource type through a single interface. Let's break it down line by line.
Async with client.
This establishes an async context manager for the client connection. It guarantees proper resource cleanup when the block exits, preventing connection leaks in async operations. The pattern is essential for managing async resources like network clients.
Content equals await client, read resource. Resource, / images / logo, PNG.
This fetches binary content from the MCP server's resource store. The await handles the async operation, returning a streamable response object that will process in the following loop.
For item in content.
This iterates through the response content returned by read resource. The resource API returns a collection of items, each potentially containing binary data, so we process them individually.
If hasheter item, blob.
This is a dynamic attribute check. It verifies the item has a blob attribute before accessing it, preventing attribute error if the structure varies. Common pattern when processing heterogeneous data from APIs or resource streams.
Print F binary content. Len item blob, bytes.
This outputs the size of the binary data in bytes, confirming the payload was received. Critical for debugging resource downloads, it verifies the content length matches expectations before file operations.
Print F MIME type, item MIME type.
This prints the MIME type of the downloaded content, verifying the resource format before processing. Critical for handling different media types correctly, like distinguishing PNG from JPEG or detecting malformed responses.
Hash save to file. With open, downloaded logo, PNG, WB, as F.
opens a file in binary write mode for saving the downloaded blob. The WB mode ensures raw bytes are written exactly as received, preventing any encoding corruption that text mode might introduce. This is the standard pattern for saving binary data like images or PDFs.
F. Write item blob.
Writes the binary blob to disk in write binary mode. This is the actual file save operation that persists the downloaded resource from the MCP server to local storage. The WB mode ensures raw bytes are written exactly as received, preventing any encoding corruption. Resource handling pattern. FastMCP's binary resource handling demonstrates the protocol's dual nature, seamlessly treating both structured text and raw bytes as first-class content types through uniform URI access. The blob attribute contains raw bytes, not a string, so attempting string operations will raise type error. Always verify content type with hasheader before processing, as resource URIs don't guarantee content format.
The resource that forgets its format becomes all format.